Okay, so now I will be going over question 29. So the first important concept in question 29 is work. So work is equal to force times distance. So I'm just gonna write that there, force times distance. So that is the concept behind work. And then work, it's also equal to the change in kinetic energy. And kinetic energy is 1/2 mv squared. Okay, so next concept, so that's just an overview of what work equals. Okay, so next concept I'm going to go over is that in an isolated system, the kinetic energy plus the potential energy will equal 0. So in an isolated system, that means no external forces are acting on the system. In an isolated system, it will equal 0. So that also means that the potential energy will equal the negative of kinetic energy. Okay, and the last concept I'm going to go over, since I've shown this here, potential energy equals negative kinetic energy, and work equals the change in kinetic energy, that means that potential energy is equal to the negative integral of force with respect to x. So it's basically showing change in kinetic energy. So it's basically saying potential energy is equal to the negative integral of force with respect to x. So that will be an important concept in question 29. Okay, so now I'm going to read question 29. The graph above shows a conservative force, Fx, as a function of position x acting on an object in a closed system. So, isolated system. If this is the only force acting on the object, what happens to the potential energy of the system as the object moves from 0 meters to 0.1 meters? So first I'm going to draw the picture right here, just to show what's happening. So this is a force with respect to x, that's just the units, and then x, meters. Okay, so this is 0. And a force is acting from 0 to 0.1 meters. So this is asking for the potential energy of the system as an object moves from here to here. So as we can see here, the area of this right here is negative. If we take the area of this force graph, it will be negative. And using the principle we showed above, the negative integral of force with respect to x is equal to potential energy. So that means that if we have a negative area here, that means that the potential energy will only increase because it's only negative. So that means potential energy will go up. And so basically the answer to this question is A. And basically what it's showing is that the total force here, it has a negative area, so that means that the potential, since it's related like this, that means the potential energy will only be increasing because it's negative. If it was above the x-axis, we can see it's below, but if it was above, then potential energy would decrease. But it's only a negative area because we can see it's below the x-axis, so it's only going to be increasing. So the correct answer is A. So in conclusion, this question shows important concepts of work. Specifically, the important one here was that work is equal to the change in kinetic energy. So that was an important concept. And then also that potential energy is equal to the negative kinetic energy in an isolated system. And that lets us arrive to the important equation that potential energy is equal to the negative integral of force with respect to time. So that shows us how potential energy and force are related, and it helps us solve important questions like this which basically showed that since force had a negative, since the force graph, we can see it has a negative area, that means that the potential energy in this case will be increasing.